Well, this is a new curve. We're going now from x squared to x cubed, a cubic.
Cubic, yeah, a little bit of a step forward, but let's not worry too much about the curve. Let's just do the algebra to figure out our best fitting straight line. So again, we want to start with the function at some x minus the function at some x naught and try to approximate that by a line. Let me pop that up for you, Matt.
Okay, let's have a look.
So on the left-hand side, you have x cubed minus x naught squared. Cubed, actually. X naught cubed minus x naught cubed. That's not quite a difference of squares, but it turns out it kind of works like a difference of squares. You get an x minus x naught, which is this term here, and then you have this other term here.
Well, that term, it's a bit fuddly-duddly to try to get it, but I can see that the first term is x squared, and it multiplies the x of the x in x minus x naught and give an x cubed.
Right.
And the same for x naught squared times minus x naught. But tell us about the middle term and what's going on.
So the middle term is kind of neat. What it does is it gives you some cancellation. So when you multiply this by x, you get an x squared times x naught. This x naught, when it's multiplied by x squared, is minus x naught times x squared. So they exactly cancel. So it works out perfectly.
Well, that's great. So what's the final answer now? We've got to replace the first term with x naught like we've always thought of because we're in the neighborhood of x naught.
So we'll get an x naught squared here. Here we replace this x with x naught. That gives us another x naught squared. And here is another x naught squared. So I've got x naught squared plus x naught squared plus x naught squared. What's that, Matt?
3x naught squared, which is our slope.
So here's the approximation. And you're right, this first term, this first factor is the 3x naught squared. That's our slope.
Well, I noticed that for x squared, we ended up with an x naught, and for x cubed, we ended up with an x naught squared, and so on. So maybe there's a pattern here that we could explore for any power of x.
That's a great idea, and I think we should do that in a separate video.